Welcome to Module 3 of this course, Security Controls Justification and Evidence, presented by the Institute of Security Architecture United. When cybersecurity practitioners work with security controls, justification is essential. Having both the knowledge and the evidence ensures we can identify, determine, and deploy the proper control. Every control must be defensible, and that means every control must carry a justification and be tested. At ISAUnited, there are 4 accepted justification categories. 1. Threat-driven, where adversary tactics, MITRE ATT&CK mapping, or red team findings show the need for defense. 2. Vulnerability-driven, where weaknesses or misconfigurations expose systemic risks. 3rd, architectural gap-driven, where the design itself lacks a defensible pattern. 4th, interoperability or compliance-driven, where consistency or regulatory requirements demand a safeguard. In this course, we will recognize all 4. In this module, we will focus on the threat-driven approach and later, in Module 4, the architectural gap-driven, because these connect most directly to ISAUnited's Defensible 10 standards and your role as cybersecurity architects and engineers. Threat-driven approach. Controls must be justified, not arbitrary. Threat-driven justification links directly to adversary behavior, ensuring that the safeguards we deploy respond to how attackers operate. At ISAUnited, we incorporate 2 fundamental threat frameworks into our methods. 1. The Mandiant Targeted Attack. Lifecycle provides a structured approach to understanding adversary behaviors, from reconnaissance through exfiltration, highlighting where the best intervention points lie. 2. The Lockheed Martin cyber kill chain breaks down an attack into 7 clear stages, from reconnaissance and weaponization through exploitation and objectives, helping us focus defenses where they will be most effective. Building on these fundamentals, ISAUnited utilizes the Technical Adversarial and Defensible Analysis (TADA) process to ensure that every control is both threat-informed and defensible against real-world adversary tactics. The TADA process, Technical Adversarial and Defensible Analysis. Now, let us go through the TADA method, the Technical Adversarial and Defensible Analysis process. This is ISAUnited's approach to ensure every control is threat-informed and defensible. The process is structured into 4 steps. The following slides will walk us through each of these steps in detail, so you can see how TADA is applied in practice. Threat Modeling, STRIDE. TADA Step 1 is the threat model. Using STRIDE, we categorize potential threats into 6 areas: spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. STRIDE is simple yet powerful. It ensures we don't miss categories of attack when analyzing a system. For example, spoofing can be associated with phishing attempts, tampering can involve SQL injection, and denial of service attacks could be a distributed DDoS attack. In practice, we can apply STRIDE to a system diagram in less than an hour, mapping these categories to login forms, databases, APIs, or networks. This gives us a quick yet comprehensive view of where threats might appear. ISAUnited has adopted Microsoft's STRIDE model as it is an industry-recognized framework that helps ensure defensibility in our threat analysis. STRIDE is also the entry point to deeper analysis. Once a threat category is identified, we connect it to adversary tactics in the MITRE ATT&CK framework. This ensures that our models are not just theoretical, but tied to real-world attacker behaviors, making our controls defensible. Threat mapping in TTPs, MITRE ATT&CK. TADA Step 2 is to map adversary behavior. Here we select 2 or 3 techniques from MITRE ATT&CK that best align with the identified threats. For example, under tampering, attack technique T1078, valid accounts, highlights the risk of compromised admin credentials. To make this practical, we also use threat mapping. Threat maps provide a visual representation of attacks, showing the type, source, and target across various geographies. They help organizations see the bigger picture and understand the prevalence of threats. We also consider attack paths, which trace how an adversary moves through a system, and attack entry points, the initial points of compromise, such as phishing emails or exposed services. These perspectives, combined with attack mapping, empower practitioners to anticipate adversary tactics and select defensible mitigations aligned with ISAUnited's Defensible 10 standards. TADA Step 3 is Mitigation Evaluation. Here we document which technical specifications, the outputs of our substandard, directly mitigate the threats identified earlier. The goal is to connect evidence of a threat to a defensible mitigation that reduces measurable risk. For example, if we identify the threat of compromised admin accounts, attack technique T1078, the defensible mitigation is to enforce role-based access control and multi-factor authentication at zone boundaries. This prevents adversaries from moving freely inside the network. Mitigation evaluation is more than listing controls. It is ensuring that each control is defensible, aligned with ISAUnited's Defensible 10 standards, and that it measurably reduces risk. Examples include using input validation to prevent SQL injection, segmentation to stop lateral movement, or monitoring and logging to detect credential misuse. By the end of this step, we have a clear map from threat to mitigation, proof that our controls are not arbitrary, but purposeful, effective, and defensible. Defensibility check. TADA Step 4 is the defensibility check. We validate and verify V and V that our proposed mitigations not only block or plug the threat, but also align with the Defensible 10 standards. A defensible mitigation is one that measurably reduces risk, improves resilience, and integrates cleanly into ISAUnited's framework. Let's do a quick knowledge check to test your understanding. Question 1. Threat identification in context. A new web application includes a login form, API gateway, and backend database. Which STRIDE categories are most relevant to this system? A. Spoofing and information disclosure. B. Repudiation and denial of service. C. Tampering and elevation of privilege. D. All STRIDE categories are equally relevant at all times. Correct answer is A. Rationale. A login form and API gateway creates spoofing risks, identity misuse, and potential information disclosure from exposed APIs or misconfigured data handling. Question 2. Validation and defensibility. Check. Which of the following best validates that a mitigation is defensible under ISAUnited's framework? A. It is easy to implement with current tools. B. It aligns with the Defensible 10 standards, measurably reduces risk, and improves resilience. C. It reduces audit findings in the following compliance cycle. D. It matches what peer organizations are doing. Correct answer is B. Rationale. Defensibility requires alignment with D10S, measurable risk reduction, and improved resilience, not just ease of implementation or compliance parity. Module recap and transition. To recap Module 3, threat-driven justification ensures every control is rooted in adversary behaviors and real-world exploits. The TADA process provides a repeatable method for connecting STRIDE categories to attack techniques, selecting defensible mitigations, and validating them against ISAUnited's standards. In Module 4, we'll look at the other side of justification, architectural gap-driven controls, using ISAUnited's architectural methods and models to close design weaknesses.